This tutorial is about writing your own analysis scripts for data generated using the Baxter algorithms. Here I have an image sequence of muscle stem cells in a bright field dataset. The microwell here has a diameter of 600 microns, and the images are taken with a time interval of 3 minutes. The magnification is 10x. And I've already tracked this in a different tutorial. Here are the tracking results, initial tracking results. Here are some slightly better tracking results using classifiers, and here is the final corrected tracking results that we're going to use for the analysis. So to analyze this image sequence, we can of course use these built-in analysis user interfaces, but if we want to do something more complicated, we will need to write our own script to perform the analysis. And to do that, you need to be running the program from within MATLAB. The deployed version of the program doesn't have this functionality. There is an example script here, analysis example.m, which loads an image sequence and plots the number of cells in each image. But now we're going to write our own analysis script. This is a useful file to look in if you want to learn how to write scripts. But now we'll create a new script. I'll call it tutorial script. First, we will need to load the tracking results into the script, and we do that by finding the experiment folder of the experiment that we processed. We go to the image sequence for which we want to load settings, or we want to load results. Now I copied that, and now I write cells equals load cells. And then the image sequence name, and then I need to give this tracking label or result label as a second input argument. So now if I run this, I've loaded a variable with 212 cells into the workspace, and then this set of cells will contain a number of false positive objects. So to get rid of those, I write cells equals R cells that removes all of the false positives. So now I have 29 real cells that I can process. If you want to learn more about what has been stored in the tracking results and how you can modify and access the data, you can go to the files which define the cell class and the blob class. So if I write edit cell, I go to this file, and this defines the cell objects which store information about the cells and the trajectories that they follow. And then there's a blob class as well, which defines the contour in a single time point for one cell. But then this cell class has, this is an array of cells, by the way. So if we want to look at the first cell, we index the first element of the cell array, and then if I run this, cells, then I get information about the first cell of the image sequence. You see that it occurs first in the first frame, and it has a lifespan of 96 frames, 96 images. And we also have some other information, for example the average speed or the average size of the cell. There's also a blob array where the outlines of the cell, or the segmentation masks of the cell in each image, are stored. And we have the three parameters cx, cy, and cz, which specifies the coordinates of the cell in each image. So if we want to plot the trajectory of the cell, we can create the figure and then plot cells 1.cx against cells 1.zy. That will plot the trajectory, and we can specify the color as the color of the cell. And that parameter is cells1.color. And now I run this, and then I see the trajectory of the first cell. We can of course write this in a loop where we plot the trajectories of all of the cells. And just to get a slightly shorter code, I assign the cell object to this variable c. So now I plot all of the trajectories, and in order to not just overwrite the plotting that I did in the previous iteration of the loop, I need to type the command hold on, and then I run this, and here I see the trajectories of all of the cells. If we want to count the cells in all of the images and plot the number of cells against time, then we can define a count variable. And to know how many images there are in the image sequence, we define an image data object. Image data, and then the sequence name or sequence path. And the sequence path is input to both the load cells and the image data functions. Image data is actually a class, so we generate an object by calling this constructor of the class. So then I define a count variable, count array, as a 0 array with as many columns as there are images in the sequence. And a single, as many rows as there are images in the sequence, and one column, so a column array. And then I write a loop where I iterate over the cells again. And then I increment the count array for each cell. And I increment only the interval between the cell, the first frame of the cell, and the last frame of the cell. So I increment this interval by 1. And then I create a new figure, and I plot the frame index against the count. I'll make the line slightly thicker. A line width of 2. And then we run it to make sure that it works. This looks good, but we should always name our axes. So we have a Y label, cell count, and an X label, frame number. Now I press F5 to run the script. That's why you don't see me doing anything. So here we can see the first cell division, and then the 2 following cell divisions. They are more or less synchronized, and then these 2 cells divide and give rise to 8 new cells. And then we have more cell divisions here, and one of the cells die here, and that's why the number goes down. This was just an introduction to writing scripts, but I hope that it was at least somewhat helpful in getting started.